Graphing functions by plotting points. Graph the given functions f and g in the same rectangular coordinate system. Use the integer values of x given to the right of the functions to obtain ordered pairs. Describe how the graph of g is related to the graph of f. So we're going to take this piece by piece. First, we're going to look at f of x equals the square root of x. And I'm going to plug in these values for x to find my y values. To do that, we'll just create a chart. Here I have a chart. My first column represents the values I'm going to plug in for x. The second column represents the function f of x equals the square root of x. And the third column will represent my ordered pair. First, I'm going to plug in a 0 for x. So I have f of 0 equals the square root of 0, which equals 0. So my ordered pair of xy, or x of f of x, is 0, 0. You're just taking the x and then the value you got in your second column. F of 1 equals the square root of 1, which is 1. And my ordered pair is 1, 1. Then I'll do f of 4, which is the square root of 4. And that's a 2. So my ordered pair is 4, 2. Lastly, f of 9 equals the square root of 9, and that is 3, with an ordered pair of 9, 3. Now that I've found my ordered pairs for my first function, I can go ahead and do the same process with the second function. So here I have a similar chart, but now I am evaluating g of x equals the square root of x plus 7. So my first column represents all of the x values that are given to me in the problem. My second column represents the function, and my third column represents the ordered pair that I'll find. So first we'll plug in a negative 7 for x. So I have g of negative 7 equals the square root of negative 7 plus 7. And that equals the square root of 0, and the square root of 0 is just 0. So my ordered pair is negative 7, 0. Next, I'll find g of negative 6. That equals the square root of negative 6 plus 7, which equals the square root of 1. And the square root of 1 is 1. So my second ordered pair is negative 6, 1. And g of negative 3 equals the square root of negative 3 plus 7, which is the square root of 4. And the square root of 4 is 2. And my ordered pair is negative 3, 2. Lastly, I have g of 2, which is the square root of 2 plus 7, which equals the square root of 9, which equals 3. So my second ordered pair is 2, 3. Or I'm sorry, my last ordered pair is 2, 3. Now that we've evaluated each function at the given x values, we're going to graph each function on the same coordinate plane. So here I have a chart, and the first column represents all of the ordered pairs that we found for f of x, and the second column represents all of the ordered pairs that we found for g of x. First, I'm going to plot the ordered pairs for f of x. So my first ordered pair is 0, 0, that's right here, and my second ordered pair is 1, 1. So I go to the right 1 and up 1. Then 4, 2, I go to the right 4, up 2. And 9, 3, I go to the right 9 and up 3. So my function looks like this. Now I'm going to plot g of x, and I'll do that in red ink. So I'm first going to plot negative 7, 0. So I go to the left 7, and then negative 6, 1, I go to the left 6, up 1. Then negative 3, 2, go to the right, go to the left 3 and up 2. And lastly, 2, 3, I'm going to go to the right 2 and up 3. And then I'll graph that function. So as you can see, both functions have the same shape, but the graph of g of x is shifted to the left. Now in our problem, we're asked to describe how the graph of g, which is the red graph, is related to the graph of f, which is the blue graph. So if we look at the red graph, we can see that it was moved to the left 7 units. So we can count 1, 2, 3, 4, 5, 6, 7. So each one of these points is moved to the left 7 times to get the point on the red graph. So our transformation is that the graph of g is the graph of f shifted left 7 units.